David Smith here with one more flipped classroom math lesson. 3 tips before we start. First, remember that you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to jot down some notes or write down some questions for our next class. Lastly, you could turn on the captions so you can read my words go by on the screen. Today's topic, negative and complementary angle formulae, which is plural for formula. Let's look at negative angles first. The negative of theta is just written negative theta. Pretty straightforward. On the unit circle, we go theta up. That's the positive direction, counterclockwise around the unit circle. So negative theta is theta down, and the clockwise direction, which is the negative direction on the unit circle. So theta is the same angle in each of these cases. They're just rotating different directions. Now let's take a look. X-coordinate for theta is cosine theta, sine theta. And we know from previous work that the x-coordinate here for negative theta is just cosine negative theta, sine negative theta is the y-coordinate. So that's how that works. Now, we have 2 rules here. Now, pause the video and see if you can figure out what the cosine of negative theta can be written as. And part of the answer to these 2 questions involves looking at the unit circle. Okay, the first one. Cosine negative theta, check this out. There's cosine theta right there. Here's cosine negative theta right here. We're still to the right of the y-axis. It's still positive. So what that means is that the cosine of negative theta is going to be the same thing as cosine theta. Okay, so the first formula here just tells us that cosine, which is the x-coordinate, is always going to be the same regardless of whether it's negative theta or positive theta. Now sine is a little different, so think about what you could write for that. Okay, so check it out. Sine, being the y value, is for negative theta, we're down below the x-axis, and sine of negative theta in this case is going to be a negative. Now sine theta is above the x-axis, so it's going to have the opposite sign of that. So what we write here is negative sine theta, because sine theta is going to have the opposite SIGN sign from sine of negative theta. So to make these 2 things equal, we have to throw a negative on the outside there. Okay, now let's take a look at the complementary angle formula. This one's a little bit more complex, but in practice it's easy to use. So first off, complements. 2 angles are complementary when they add up to 90 degrees. This is a definition from probably 2 or 3 years back in your geometry studies. We have complementary angles, they add up to 90. Okay, so in this unit, we're also going to call 90 degrees pi over 2 radians, as you'll recall. So either 90 degrees or pi over 2 radians. Okay, so here are the 2 left-hand sides of the formulae that we're going to use. Check this out. Cosine of 90 minus theta. So 90 minus theta is the complement of theta, because then theta plus whatever this angle is going to add back up to 90. So cosine of 90 minus theta is just going to be sine theta. And sine of 90 minus theta, as you might have guessed, is going to be cosine theta. Now, let's take a look at where that comes from, because this might seem a little strange to you. Check this out. Here's theta. We've rotated up to point B, okay? Here is 90 minus theta. We've rotated all the way up to P prime, okay? Now, these 2 points share this interesting property. They're the same distance away on the unit circle from the line y equals x, which has some theta of 45 degrees. So they're symmetrical about that. So if you reflect one to the other, it's going to map perfectly. So these 2 points will reflect across the y equals x line. And what that means is that the xy coordinates of each of these 2 points will just switch. So whatever x is here, it becomes y for that point, and whatever y is here, it becomes x for that point. Okay? So you might remember this from our translations unit. So what that means is cosine of 90 minus theta, or cosine of the complement of theta, is just going to be equal to sine theta. That's that switch. And the same thing for sine of 90 minus theta, that's just going to be equal to cosine theta. Okay, let's do a couple examples. Feel free to pause the video at any point and try to work these yourself. Take a look at those laws we did with the negative and the complementary angles. Those are your keys to doing these problems. Okay, let's take a peek here. 5 sine theta minus 2 sine negative theta. Okay, so to combine these with the rules we got in a prior lesson, the thetas need to be the same. So sine of negative theta is the same as negative sine theta. So we can change that up. It'll change this SIGN right there. So it becomes 5 sine theta plus 2 sine theta. So again, what we did is we took this negative and we popped it out. Remember that one rule was sine negative theta is the same as the negative sine of theta, like that. Okay, so I just used that rule on this expression. The negative came out, it went in front of the sine theta, and I already have a negative there, so this becomes positive. Now this we can evaluate using a prior rule. This becomes 7 sine theta, like that. Okay? Now you can drop your parentheses. Notice how I'm kind of mixing it up. You can drop your parentheses if you like. Just makes it go a little quicker. Okay, let's take a look at this next one. We would love for these cosine theta to be the same because then we can combine the terms. Fortunately, we can do that. Cosine of negative theta, remember that one, cosine neg theta equals cosine theta. There's no change in the x-coordinate, so this becomes 4 cosine theta minus cosine theta, which is 3 cosine theta. Like that. One more example. Check this out. 4 cosine pi over 2 minus theta minus 3 sine theta. So right now, I don't see a way I can combine these two terms yet, because I got a cosine here, a sine there. I don't have a theta there. I have a pi over 2 minus theta, whatever that is, and a theta there. So I've got some work to do. So here's a rule that I need to remember from just a minute ago. Cosine 90 minus theta equals sine theta. We got that from our complements. So cosine pi over 2 minus theta, pi over 2 is 90 degrees. So this is cosine theta. So we're going to change this to sine theta. So this becomes 4 sine theta minus 3 sine theta. Suddenly, this problem gets nice and simple. This just becomes sine theta, like that. Now I want to say some words in closing. These problems are interesting. They're kind of algebraic, and then they have a lot of substitutions. And that's the key to solving these, is you have to look back on the rules and the laws that we use to evaluate these expressions to figure out what you can substitute where, so that then you can combine some terms. Like for example, this cosine 90 minus theta, you had to remember this law here to substitute in the sine theta for that, so you could combine your terms. Now that you've watched the video, jot down some notes, some questions, or a quick summary of the lesson. You can also re-watch the portions of the video that challenged you the first time. If you enjoyed the video, please click like. If you'd like to help me grow my YouTube channel, please click subscribe.